everyone, and welcome to today's webinar session. My name is Joseph Mutua, a solutions architect at AWS, and today we will learn how you can build containerized applications on AWS. In our session today, we will quickly review why customers adopt containers. We will then look at container orchestration options available on AWS, where we will learn about Amazon ECS, Amazon EKS, and touch a bit on AWS Fargate. For observability and visibility into your deployed applications, we will review Amazon CloudWatch Container Insights, then touch on service discovery using AWS App Mesh. I will try and make this session as interactive as possible with some demos in the course of the webinar. So hopefully you're going to enjoy it. So why are customers adopting containers? Because of, various customer needs, some of which are listed here, we've seen a large push towards containers. By letting AWS handle infrastructure and operational burden and provide automation, customers are able to reduce risk and focus on building business logic instead of infrastructure. By moving to a controlled and repeatable environment and embracing automation, we see product delivery velocity dramatically increase while improving quality, stability, and security. So what are customers really building? It ranges from applications to machine learning solutions. So in applications, our customers are building the backend services that power their IT organizations and the customer applications that drive their top line growth. We also see many of our customers building shared services platforms to help their development teams move faster. So these platforms automate software deployment and infrastructure provisioning and provide guardrails for management, security, and governance. We are also seeing customers, containerizing their legacy .NET, Linux, and Java applications and moving them to AWS. And finally, like mentioned, we see machine learning as a large and growing use case as well. For example, in the space of autonomous vehicle workloads are a huge use case for AWS container services. So let's look at the container stack on AWS. So if we look at the container stack on AWS at a high level, we can see that you're provided with a broad and deep set of services to help you build your containerized applications. There is a wide set of deeply integrated services ranging from container services, container registry services, networking and content delivery, to application integration and storage. And we will be going deeper into the services which can help you get started shortly. So let's get started on container orchestration, right, on AWS. And in this section, I will be taking you through, several container orchestration technologies on AWS, such as Elastic Container Service, Elastic Kubernetes Service, and Amazon Fargate, which I will then follow up with a demo on how to build a simple application. So really, what is ECS? And in this case, Amazon Elastic Container Service. So this is a fully managed container orchestration service that helps you easily deploy, manage, and scale containerized applications. It is a fully managed control plane, and customers do not have to manage, patch, or upgrade anything for ECS control plane. So, at best, it's free, so there's no charge for the service. You only charge for the underlying resources that you provision. So when we ask our customers what do they really like most about Amazon ECS, and it's the fact that ECS is simple and it provides an opinionated way of running containers on AWS and at scale, and it reduces the time it takes customers to build, deploy, or migrate their containerized applications successfully. So, I would say, and I can tell you that Amazon ECS powers a growing number of popular AWS services, trusted by hundreds of thousands of customers, including the likes of Samsung, General Electric, Expedia, and Duolingo. So you can check those public use cases. And customers are actually adopting containers at scale and seeking powerful simplicity with Amazon ECS. So let's try and deconstruct, Amazon ECS to understand its simple yet powerful core constructs. So we have tasks, and tasks consist of one or more containers. This is your application, typically. So you can run the task on either an EC2 instance or on Fargate, or their sport variants. So there is EC2 Sport, there is Fargate Sport as well. And then multiple identical tasks make a service, and tasks in a service can be connected to a load balancer, which also automatically gets done by ECS. And we refer to a group of services and tasks as a cluster. So as a customer, you can create as many clusters as you want and map them to your different teams and create them for specific workloads, because a cluster is just a simple logical grouping. So ECS also comes, and provides auto-scaling and self-healing functionality. So with ECS, you can easily scale up and down the tasks as you need them or as they are needed by the application demand. And moreover, tasks can be spread between, Fargate, on-demand, and Spot, which is great for cost saving. And if a task dies, ECS will replace it automatically. So a little bit on ECS Fargate, and how exactly that sits in the space of ECS. So we already know that ECS is fully managed control plane, right? Now with Fargate, then this is a fully managed data plane. That is, the compute which runs the containers is managed by AWS, and you don't have to manage it as a customer. So you don't need to maintain any Amazon machine images, which is a big operational saving. Additionally, like I mentioned earlier, Fargate Sport and savings plans can be leveraged to provide even further savings for your infrastructure. Then enter ECS Anywhere, which is a total game changer. And previously you could run ECS only on Outpost or in an AWS region, in a local zone, or AWS wavelength, or you could only run it in AWS Fargate. However, customers no longer need to operate a separate local container management software such as Mesos or Kubernetes if they want to have a single plane for their container orchestration, because ECS now helps customers actually standardize the management across all their environments, and it enables the ability to add on-premises environment to ECS, which completely helps simplify and reduce the complexity for customers migrating container workloads to the cloud. So some of the key use cases of ECS Anywhere I would mention are, for example, hybrid environments where, as a customer, you're able to consistently run workloads on cloud and on-premise. Then there is, in modernization efforts where you can leverage ECS Anywhere to, be like a platform to help you containerize any existing on-premise apps before you consider migrating them to the cloud. And then in IoT for data processing on edge locations. So that's the bit of theory on ECS, and I want to now take you through a demo on how to go about creating or running a simple application using ECS. So I will change to my console. So this is the AWS console. So for us to get to ECS, I just need to type here ECS in the service. I can also find it here in the recently visited services. So I'll click on Elastic Container Service. So this brings me to the ECS console. So to start and to be able to deploy an ECS cluster and be able to run an application using ECS, you first start by doing a task definition. So I will create a simple task. We're going to call it, okay, before we give it a name, let me just first show you the launch types. It's either Fargate, EC2, or external for ECS Anywhere. So in our example, we are working with EC2. And to create this, there is parameters that you specify like task and container definitions, IAM roles, the task size, container definitions, various constraints, and any volumes that you want to leverage to persist data. So I'll use as a JSON file to do this configuration. I have a file prepped for a simple task definition in order to save time. So, 10 CPU units, about 300 MB. We know it's running Apache, and we're going to call it simple app. So let me call it as webinar task definition. And I'll save that, and I'll create that. So we have our first, task definition. So with the task definition, the next thing that I need to do is to go and create my cluster, right? So you remember in my task definition, I provided the container. So let's just look at it actually. We provided a container, right? We've given it some resources. In the container, it's a simple index HTML page that's going to be getting presented. Our host listens on port 80 and the container listens on port 80. It's TCP protocol, and it's open at the moment to the world. So as soon as I spin it up, I should be able to actually access this service. So let's go to clusters. Oh, sorry, this has moved to unnecessary. Right, yeah, so I'm going to create a cluster. And in clusters, you have got 3 different ways of creating clusters, right? So we've got, let me talk about the first, these two, this and this one. So EC2 Linux plus networking, it's if you're using a Linux AMI. And then we have EC2 Windows plus networking if you're using a Windows AMI. And then we have a third one, networking only, which is if you're going to be deploying your cluster using AWS Fargate or external instance capacity in the case of ECS anywhere. So in our example, we're using a Linux AMI. So I'm going to select that. Then we need to give our cluster name, right? So I will call it webinar demo app. I'm going to change the instance size because it's just a demo. So I'm going to run it using T2 micros. It's the smallest you can AWS instance. I'm going to spin it up with only one instance just for the demo purpose. I will not create a new VPC because I have already pre-created VPC. So I will select 2 subnets. I will assign a public IP address just in case we need to troubleshoot the instance that will be, running our containers. And then I will enable CloudWatch Container Insights because later on in the webinar, I'll be talking about CloudWatch Container Insights and the value that brings as far as monitoring and troubleshooting your containerized solution is concerned. All right, so quickly, I will spin that up. So this is going to create an ECS cluster for us now. So let's just give it a bit of time. Should be done shortly. Normally it does not take very long. So, and as you can see, it's actually behind the scenes provisioning a CloudFormation stack to manage, the different resources, the autoscaling, the EC2 instances behind the ECS cluster. So let's look at our cluster now. We have our cluster. We call it Webinar Demo App. It's got no service. It's got no tasks running in it. But remember, we have a task definition, right? So after creating the cluster, then to stand up a service and use the task definition that we provided earlier on, I can come and create a service. It will be in EC2 mode. I'm gonna be using webinar task definition, which is the latest one that we spun up. The cluster is webinar demo app. Set this to that. So let's give it a name, demo app. A number of tasks, we'll just spin up one. The other parameters are going to leave in default, will not change anything, just for simplicity.
Then next is a section to configure networking, because it's just to show you how you can quickly get started. We will not be setting out any load balancers. However, with ECS, you can actually be able to expose your services using an application load balancer, or a network load balancer, or the classic load balancer. So these are all available. And then we have got service discovery as well, and I will touch a little bit on service discovery towards the end of the webinar. But for now, this is optional, so we are not going to be enabling this. But the essence of service discovery is when now you have too many microservices and you're trying to figure out a scalable way of getting inter-service communication. So there comes a service mesh. Right, next, I'm not going to enable any auto scaling, so I'll just leave it as it is with the desired number that we set out. And then here you're presented with a summary, and I create the service. So the service is going to be getting created, and it transitions through different states. It can either be in pending, or when it's ready, we'll see it in running. It will change this status to running. And then we are going to be able to access it. So as we are waiting for the service to get ready, I would say, let me first touch a little bit on container registry, because you'd also want to know what options are available in AWS as far as container registry is concerned. So let me go back to the presentation. So as far as container registry is concerned, AWS provides it with Amazon ECR, which is a fully managed container registry service, which makes it very easy for you to store, manage, share, and deploy your container images and artifacts. So you can leverage it if you want to have a fully AWS within the AWS ecosystem driven solution. And then with Amazon ECR, you do not need to operate, your own repositories or worry about scaling or the underlying infrastructure and their availability, because Amazon ECR will host your images in a highly available and high performant architecture, allowing you to deploy your images for your container applications reliably and when you want them. So to also mention, you can actually share your container software privately within your organization if you wanted, or publicly for other developers out there to discover and download any software that you might want to open source. And also, as a developer, you can actually search the Amazon ECR public gallery for an operating system image that is geo-replicated, for example, for high availability or for even faster downloads, depending on where you're deploying your ECS cluster. All right, so that's just a little bit that I wanted to touch on as far as container registry is concerned. So let's go back to our service and check whether our service is now ready, up and running. So it's webinar demo app. Yes, now the last status is it's running. So we can open it, and then we can expand this to get the link on which we can reach the service. So practically, we should see this web page displayed if we navigate to this link. So pretty simple, Amazon ECS sample app, congratulations, and you're told that your app is now running on a container in Amazon ECS, and it's that simple. So you can think about the container that you use as your Docker container, where you've built your application and you've kind of you have taken it to a step where you either want to test it and test its functionality. So you just follow the same steps and configure your ECS cluster. Okay, so that kind of marks the end of ECS, and I want to go on to the next container service in AWS, and this is for the for the Kubernetes lovers out there. And I'd like to mention it to you that AWS is the best place to run Kubernetes, and 65% of organizations choose AWS to run their containers. So
feedback from our customers really drives a lot of the products that we build. So we've listened to our customers, we listened to them, and we heard from them that running their own Kubernetes clusters increased the operational overhead. And I mean, we know that teams choose Kubernetes for its vibrant ecosystem and community, consistent open source APIs, and the broad flexibility. However, you'll agree with me, managing Kubernetes at scale is hard. And running clusters at production scale is complicated and requires trained resources who spend a significant portion of their time, managing upgrades, monitoring, and scaling the control plane. Then, deploying and managing the lifecycle of operational software and more. And, all of this effort does not really move the business forward. And our customers want to focus on applications and ideas that would allow them to deliver new products to their end users. So this is why, a lot of customers on AWS have come to rely on Amazon to handle their undifferentiated heavy lifting of security and operating Kubernetes at scale. So let's talk about Amazon EKS in this case, and what it is, and some of the key attributes. So Amazon EKS is a managed service that you can use to run Kubernetes on AWS without needing to install, operate, and maintain your own Kubernetes control plane or nodes. So a few key attributes that our customers have come to appreciate about Amazon EKS is, firstly, we do not modify open source Kubernetes. EKS is fully upstream, and it is certified conformant Kubernetes. So we even backport security fixes to ensure we are consistent with open source. We then support, upstream versions for a longer period, and we support up to 4 versions of Kubernetes, which gives our customers sufficient time to roll out upgrades. As part of this, we even backport patches and fixes and upgrades to Kubernetes versions, even the ones that the community may not currently support. So, lastly, we want to reduce the complexity of Kubernetes operations. So we provide the managed Kubernetes experience where we do a lot of the work to select the right Kubernetes version for you, validate dependencies to provide security, stability, and operational excellence that our customers rely on us to deliver. So, as AWS, while majority of our customers choose an AWS managed service to run their workloads, we also recognize that customers have specific needs to self-manage Kubernetes on AWS. And we are committed to providing the best experience regardless of how our customers choose to run Kubernetes on AWS. So on security, and security has been and will always be job zero at AWS. We are actively involved in the Kubernetes community to shape the security roadmap of open source Kubernetes. And we have open sourced components to simplify the deployment and management of Kubernetes on AWS. Some of those components you can see is the cloud provider, AWS, down to the autoscalers, AWS FSx CSI driver for storage, all the way down to AWS encryption providers if you want to do some encryption on resources within your Kubernetes cluster. Then, of course, you would ask, but then does it have, a Fargate equivalent like we saw in ECS? Yes, it does. So there is, the serverless compute platform for containers for EKS as well. In this case, it's, Amazon EKS on Fargate. And, the difference between using EKS and ECS with Fargate are really driven by the orchestration system. Right. Additionally, Amazon EKS is available anywhere you need to deploy your application today. So we offer multiple deployment options for Amazon EKS, from EKS on AWS to Outpost, local zones, to deployments on customer self-managed compute with EKS anywhere. And we now have EKS distro, really, which, the customers can use their preferred tooling or use it with a partner solution such as Rancher or Tanzu. All right, so let's look at EKS and have a quick EKS demo. So I'll switch back to my console and go to clusters, EKS. So to provision an EKS cluster is different ways you can do it on AWS. You can have, you can use EKS control, or you can use AWS console, or you can use AWS CLI. In our example here, I'm going to use the AWS console, but then also I'll run some configurations activities using kube control, which is a command line tool for working with Kubernetes clusters. All right, so some prerequisites, of course, you need to have, the latest version of AWS CLI installed that, can work with AWS services that include EKS. Like I said, we need to have kube control, which is the command line tool for working with Kubernetes, as well as the relevant identity and access management permission, so that as the principal that is trying to configure these resources, I'm allowed to work with EKS and other services like CloudFormation and VPC that are going to be required to create the EKS cluster. All right, so to create a cluster, I'm going to quickly just add a cluster here. We are going to call it demo webinar. We're going to run the default, which is 1.21. So for the role that we are going to use my Amazon EKS cluster role. So this role allows you and enables you for the Kubernetes control plane, to manage other AWS resources on your behalf. In this case, things like EC2 or other AWS services that you might want to leverage as part of your EKS cluster. So we'll go and use the containers VPC. It has two subnets. We'll use a default security group. For cluster endpoint access, we've got public and private, and we've got private. And for public, it pretty much means that the endpoint is accessible from outside of your VPC, while the worker nodes traffic will leave your VPC to connect to the endpoint. For public private, the cluster endpoint is accessible from outside of your VPC. However, the worker nodes traffic to the endpoint stay within the VPC and never leaves the VPC. In a private endpoint access, then the cluster endpoint is only accessible through your VPC. So you either have a Bastion host or a VPN connection to your VPC to be able to access it, and your worker node traffic to the endpoint stays within the VPC. Right? So we go next. I'm going to use this as the default, just show you the simplicity. Right. So our cluster is going to get created. Now, this takes a bit of time. And, for the sake of saving us time, I prepped a cluster beforehand so that we're able to quickly accelerate. So the cluster will get created and it will become active. And when it's active, the next thing that now you need to think about is being able to, get your developer desktop or your builder's desktop to have to communicate with your cluster, right? So for that, I'm going to be using, like I said, it's AWS CLI as well as kube control. So for this, I need to create a kube config file for my cluster so that I'm able to access it. So my kube config file, let me get it. It's very simple. So these are calls I'll be making from the CLI. So it's AWS EKS update kube config. The region is US East. The name of my cluster is my cluster. So I can have many, different clusters. So depending on which one I want to access, then I just need to change the context so that I have access to that particular cluster. So I can now confirm that I have access to, or I have gained access to the cluster. Yes, I can actually do that. That means we can actually check for
things like the default namespaces that come with it. So it's kube node release, kube public, kube system, and the default namespace, right? So there we go. I mean, we have our cluster. Now, this is not enough, right? You need to be able to deploy, some resources. For you to be able to spin up containers, you need some compute resources. At this point, our cluster does not have any nodes, right? And this is what is going on here. Our cluster will be created, but it will not have any compute. It will only have, the networking that we specified within the VPC, but nothing else really. So for the cluster which is running, and in this case, my cluster, for you to create or to attach, resources to create, for you to be able to place your containers, then you add a node group, right? So what I'm going to do is, just a second, let's go here, we go to compute, and then I add a node group, right? So let's call it demo app. We are going to use a node role because you want your nodes to be able to make certain calls on your behalf to different AWS services that you want to take advantage of. Right? So I'll call that, then I'll go next. I'll select, Amazon. I can either be GPU enabled, ARM. I'll work with the default one. It's on demand for now, but you can also do spot if you want. Instance type, let's work with the smallest. We'll set a disk size of 20 for our nodes. Minimum size of our nodes, we'll set it to 2, maximum of 2, and a desired of 2, so that at least we're able to place some services. The rest we leave as default. We go next. Quick summary here, and we create. All right. So this is going to create EC2 resources, as part of our node groups for us to be able to place, containers and so on. So I had created a node group before, which I call my node group with two nodes. We can confirm whether this is available. So kube control get nodes. Right. So we have 2 nodes and they're ready. I have not deployed any service. There's no namespace. There's no container in these nodes. But basically, you've seen how easy it is to stand up a Kubernetes cluster on AWS, because it just needs you to create your cluster, then come and create your node groups, and then as soon as that is available, then we'll start placing our workloads. So let's so this is still creating, so I'm going to leave it, but that does not stop us from proceeding. So once you have your nodes, your node groups active, that means then now you're ready to start, deploying simple applications. So let's try and deploy a very simple app. So we'll first. So out of this, beyond this now, everything else will be happening from your CLI, your Kubernetes cluster management tool. And in my case, it's kube control. Right. So to create a namespace, we're going to call it demo app. So we can confirm whether that has been created. Yeah, we have demo app. Fantastic. So once we have our namespace, then now we need to create a Kubernetes service and a deployment. So I have, we're going to create a simple, service and deployment YAML file, which we are going to use to deploy our service. So let's check what's here. right? Good. So our namespace was demo app, is demo app rather. So that's the only thing I need to change really. The rest is a service definition. So, you specify the name of the service, then you specify the namespace where you want it and you attach a label to it. Then you specify some specifications here, your listener ports, your host port. And then there is the deployment and the deployment manifest is here. So you specify the name of your deployment. Let me call it actually demo deployment. Call this demo service. So that in case we have others running, we can actually be able to identify. Right. So these are the only parameters. I mean, I have a container, it's an Nginx container. I'm calling it or I'm retrieving it from ECR, from the public repository, and the container port is 80. So I'll save this. And then I will apply that file. So it's kube control apply NSF, then our sample. Right, so it's created our demo service as well as spun up our deployment. Right, so let's see what is going to be running in our namespace. It was demo app. Let me actually clear this so that I bring this to the top. Yeah, so as you can see, we have a pod. We have one pod running. It's ready. We have our service running. Then we have our deployment here. It tells us 101 is ready. It's up to date and it's available. And for our replica sets, in case we need to scale this up, we've got a desired of 1 and a current of 1. So that's right there. We've created an Nginx service in our cluster, and that's how you pretty much start running your Kubernetes cluster. You can make your deployments, deploy your services, deploy multiple containers to create a wholesome solution. And then I can also quickly view the deployed service and the details of the deployed service. So all this is now Kubernetes stuff. So give me a second. So I'm using, the command line tool available to me to do this. So to check that, I can just do, Kubernetes control, kube control -n. My namespace is demo app. And then I can describe a service. In our case, our service is called demo service. Right, so when I describe the service, in the output, I can see, there's a value of IP here. So what this means, it's a unique IP that can be reached from any pod within the cluster. So this is IP that, other pods are going to be using to reach this particular service in case they need to get, to access it. We can view the details of, one of the pods that has been deployed. So control -n, demo app, describe pod. So let's see one of this. There you go. So you have all the details for that particular pod. I mean, the deployment, several details really. I mean, in the output, we can see again the IP, this unique IP here. So this is a unique IP that is assigned to the pod
from the range, from the VPC range by default. If you prefer your pods to be assigned IP addresses from a different IP address range, you can actually change this default behavior, and this capabilities provided in a CNI custom networking plugin. So that's an extension that you can actually take advantage of. And then you can also see that the Kubernetes scheduler schedules some pods. It tells you actually where it scheduled the pods, right? So it actually tells you where it scheduled the pods. Yes, so it goes ahead and shows you where those where the pods got in which instance your pods got scheduled. So right there in 10.0.3.54. So this actually is where that particular container got scheduled. All right. So with this, beyond this, you can now extend this as much as you want. You can see a bit of detail on what actually happened during the deployment of the container. We started in Nginx, we created the container, we pulled the image from the public repository, and then we assigned it to the deployment, eventually up to the point where we started in Nginx. Right? And that tells you just how you can quickly spin up a Kubernetes cluster. Now, remember, there is more extensions to this. You could go ahead and deploy your vertical pod autoscaler so that you can scale your Kubernetes cluster. You can deploy an horizontal pod autoscaler. In this, you can do network load balancing, application load balancing, and build an ingress so that you can expose your microservices to the rest of the world, or to any users that want to access it. So that is the EKS demo. Let me go back to the presentation. Right, so you can use this QR code to actually get some documentation which shows you how to get started. Now I'd like to have a conversation around Amazon EKS or Amazon ECS, and which one and at what time. So the choice of the orchestrator is important, because if you think about it, this is the key integration point, and it will deeply influence the rest of your choices as far as what AWS services you're going to be consuming. So one of the most common requests that we hear from our customers is, can you help me decide which container service to use? And in AWS, our recommendation is, that teams can begin by selecting a container solution with the attributes that are most aligned to the application requirements or operational preferences. If you go the ECS way, then you're getting advantage of powerful simplicity, as you might have seen. If you go the EKS way, then it's open flexibility, and you're able to bring your already existing practice on Kubernetes onto your EKS clusters. So that's I would say would be the differentiator in this case. So both of them support a broad array of compute options in AWS, and we have deep integration with other AWS services so that you can get the global scale and reliability that as a customer you've come to expect from AWS. All right. So I'd like to touch a little bit on observability. And remember, when we were working through the ECS cluster, I actually enabled CloudWatch container insights. So, visibility or observability in the cloud is necessary, and because it's required for the collection of three things: metrics, logs, and traces, and you want to see what's going on. So in AWS, you've got CloudWatch and AWS X-Ray. So both of these services allow you to collect cloud and on-premise, metrics and logs and traces. And if you think about it, it's all about data. You'd rather have these logs collected than not have them collected. So if you think about CloudWatch, you're going to be able to get metrics, logs all the way to alarms and build dashboards out of it.
On the side of X-ray, then you're instrumenting your application and you're able to do tracing, debugging, and build service maps, to figure out things like latency, know which microservice is causing, the application to misbehave. And it's both, from a server and from a client perspective. So let's just narrow a little bit on CloudWatch and, see what CloudWatch is. So with CloudWatch, like I said, you're able to collect, monitor, detect events, act on those events that you've detected by automating and remediating, using other AWS services like, creating a CloudWatch event to trigger a Lambda function, which goes ahead and, runs a specific remediation. And also you're able to analyze and diagnose, whatever is going on in your platform because you've collected these events and metrics. So CloudWatch is actually there to help you, achieve these particular solutions, and it's built to handle high scale, because just like every other AWS service, operational excellence and security are our number one priority, and this is built into CloudWatch because we know how important it is to be able to handle high scale data volumes and be able to deliver that to you as a customer. It's cloud native and provides you with a single solution for both metrics and logs. And finally, it enables you to automate your monitoring using SDKs and APIs, as well as command line interfaces. All right. So CloudWatch Container Insights, which is what we enable in our ECS cluster. Ideally, it's a fully managed observability service. And as you saw, I just needed to check a button while I was creating my ECS cluster for it to be enabled, right? So I'm going to be able to troubleshoot any alarming for my containerized application, and I can run analytics on it. All right. So let's check actually what that looks like. So we come to our ECS cluster, right? If you come to our ECS cluster, let's select its webinar demo app. Remember, we confirmed that it was running, so that's fine. So every other request I make should generate some network traffic, which we should be able to pick. So from a metrics perspective, here we go. So you can see there was some CPU utilization, there's some memory utilization, how much CPU is being reserved from the EC2 instance for that particular container, as well as memory reservation. However, here is a link to navigate to now CloudWatch Container Insights. So let's check for this ECS cluster, right? It's webinar demo app, right? So that's what we want to look at. So we can see things like I said, CPU utilization, memory utilization. We can pick metrics around whatever is running in our cluster, like container instance count, we only have one. Task count, we only have one task running, and we only have one service running as well. So this is coming from Container Insights, and you're able to get a very nice dashboard that actually gives you some good information on what your infrastructure looks like. Right. So as far as Container Insights use cases are concerned, you can actually use Container Insights use cases in Amazon ECS. You can use it in Fargate for ECS. You can also use it in Amazon EKS, as well as Kubernetes on EC2. However, I'd actually like to navigate back to show you what other, elements you can monitor. So it's services, it's tasks. So if I narrow it down to tasks, it will show me, how much CPU utilization is going on for a specific task. It will give me details around, network that was received because of all the refreshes I was doing. How much am I writing to storage with all the requests that I'm making, and the network traffic. So there you have it. Let's go back to the presentation. All right. And you can, have it on Kubernetes on EC2. So I've shown you, the demo, so we'll skip this. So let's try and now think about the problem of microservices microservices at scale. So when you start increasing and when you start leveraging containerization and you're facing an increase of containerized microservices or are in the process of migrating a monolith into this direction, one aspect suddenly plays a very central role. And this is network communication between the parts, which is the microservices. And in the case of a monolith, communication between different modules or components is trivially in process, so you don't really have to think about it. But in a microservice setup, then you need to set up this processing of a request, and it spans a handful of services that involve the network. So service meshes actually strive to address this issue. And in this context, we refer to the whole idea of externalizing certain network traffic related functionality. So rather than implementing, for example, encryption on the wire between two services directly in the application code, you can actually offload that particular task and delegate it to something like the mesh. All right. So enter AWS App Mesh. So what is AWS App Mesh? So this is a service mesh that provides application level networking to make it easy for you to use your services to communicate with each other across multiple types of compute infrastructure. So App Mesh standardizes how your services communicate, and it provides you with end-to-end visibility, ensuring high availability for your applications. And finally, I'd like to mention that App Mesh uses open source Envoy proxy, making it compatible with a wide range of AWS partner and open source tools out there. So let's look at some features of App Mesh, and in this case, just some of the key features. It supports many protocols, including HTTP 1 and 2, as well as gRPC. And then, while we support TCP, most of the features are built around at least HTTP support. So, it replaces the need for you to have a load balancer by, providing you with granular traffic controls between services. And, you can automatically collect observability data and transparently encrypt traffic in transit using App Mesh. And finally, I'd like to mention that App Mesh supports a number of compute options and multi-cluster, multi-account architecture. So you can, extend and leverage App Mesh as much as you want. So let's bring this all home now. And if we try and reflect on the session that we've just had, customers today are building more quickly and efficiently than ever, and in production at scale and around the globe. So if you look at the AWS ecosystem, we have a full stack of services beyond what I've taken you through. And these technologies and tools are there and available for every workload, both specific to containers and to integrate with the breadth of AWS capabilities. And we have much more to come in the future. So thank you for spending your time with us today, and we look forward to building containerized applications on AWS with you. Thank you very much, and goodbye.